Alright, so I am currently gone at MSU today. What a wild turn of events of the last few days. Not only have we had 3 days off, I get the full week off because I'm at MSU for today. So, in spite of that, in trying to figure out what I was going to make you guys do, I have made a fun worksheet. Now, on the back is where we're going to start. So you have the funny little conveyor belt on the front side. We're going to flip to the back and do some recalling of some old concepts that we have learned beforehand. And those concepts are going to help us kind of piece together this whole worksheet. I do not have the worksheet. I'm going to be working with it on paper because I don't have a printer at my house. So we're going to recall interior and exterior angles. Now remember, we're gonna just draw a triangle because triangles, funny enough, have interior and exterior angles. And below hand, we have some triangle work that we are going to be using. That did not make sense. Anyways, interior and exterior angles. Remember, interior angles are the angles on the inside. They are angles inside a polygon. And for exterior angles, I'm going to kind of extend this picture a little bit. Exterior angles are the angles outside of the polygon. Now, I forgot to even mention that this is the start of a new unit. Yay. Start of a new unit. Woo! Knowing these two concepts is what's going to help you kind of piece together what this unit is about, which is about polygons just in general. Triangles are a polygon. Polygons are shapes. And we're going to be using triangles since we know so much about it. And apparently I am the #1 triangle supporter since the fact that we've had a whole unit on triangles, chapter 5, and we had triangle day before. Triangles are my best friend, and we're going to be using them today to kind of help us piece together what the heck we're doing. So I'm going to move down, and you can write this in the triangle section of your paper. I have it pulled up on my tower right now, and I'm trying to copy the paper as best as I can. Triangles! So this is where I'm going to draw a triangle, and kind of just going through some of the things we know about a triangle, and the properties of this triangle can kind of help us piece together what we can do. So there are some things about triangles we can do. First off, we can sum up the interior. Sum up the interior angles. That's one thing we can do. And if I do that, and let's just say this is a regular triangle. What does regular mean? So I'm going to say this is a regular triangle. What's a regular triangle? You might be asking. Now, this doesn't look like a regular triangle once I explain it. So I'm going to say that regular means polygon has all congruent sides and angles. So regular means that all sides and angles are congruent. So an example of a regular polygon that we have seen before is an equilateral triangle. Remember the triangle that has everything congruent? Like all the angles inside are congruent and all the sides are congruent. This is technically a regular triangle. So I'm going to write AKA regular triangle. So this word regular is going to come up a lot. If I jump back up to here, I can sum up the interior angles. Since this is a regular triangle, all angles are congruent, and we know on an equilateral triangle, all the angles are 60 degrees. So if I add 60 plus 60 plus 60, it is equal to 180 degrees. So I summed up the interior angles right there. There's another thing that I can do, and that is counting the sides. How many sides are there? There are 1, 2, 3. 3 sides. And all right, I think that's good. So 2 things that I can kind of piece together of this triangle right here. We got regular down. Keep this in mind as we go through. And yeah, this is going to be it for the back side. We're going to flip back over to the front side, and I'm going to explain a little bit what I'm asking you guys to do, and then I'm going to set you guys loose in the classroom. So, I am asking you, okay, I'm just going to read it out loud. We are going to take what we applied with triangles and apply it to all different kinds of shapes. In the table below, you will be doing the following. You will pick one of the vertices of a polygon to be your focal point. Draw diagonals from that point to create as many triangles as you can. This is why it's called Triangle Factory. And then you will fill out each column with the information that you have gotten. All right. So the questions that are being asked are the same kind of deal that we just worked with these triangles. With trying to find the sum of the interior angles, how many sides there are, how many degrees is each angle in a regular polygon of this shape. I'm going to be having you guys figure all of this out by creating triangles. This is where step 1 comes into play. And I'm going to do the first one with you guys. So I'm going to draw out my square. I mean, I guess it is a square, but we're going to use a nicer term for it. The polygon name of this, it is a quadrilateral. I'm going to use the official term for this one. It's a quadrilateral. I almost knocked over my Propel bottle right next to me, and the cap is open. All right, we got its name. How many sides does it have? We read all rated 2, 3, 4. It has 4 sides. And all right, now it's asking how many triangles does it form. This is where I'm going to be picking a point on this triangle that we are going to be using. I'm going to zoom in for this one so you guys can actually see it. Zoom in even more. So you pick one of these points on here. I don't know, I'm picking this point right here. You could pick any corner you want. It's a vertice. You pick a corner. From this corner, we are going to try to draw as many triangles as we can in this box. But it has to go from vertex to vertex. I can't do like, I'm going to draw a square off here. I'm going to draw one like right here. I can't do like this and make like all of these triangles. Not allowed. That is not allowed. I will not allow that. You have to do it from vertex to vertex. From corner to corner. That's how you form a triangle and how we can fill out the rest of this. So I'm going to try my best to go from this corner right here, and I'm going to go to each corner and try to make a triangle and see what happens. So if I go from this corner right here all the way to here, I do not get a triangle. It is a straight line. If I go from this point here to this corner down here, look at that. I got some triangles made. I got one triangle and I got two triangles. And then if I go from the corner to this one, nothing is made. So I got two triangles formed. So in a bigger shape, you are going to, like, let's say the pentagon. You're going to pick one of the corners, and then you're going to go from that center point that you picked down all the way to each of its other corners, seeing if it forms triangles. That is your goal. I kind of gave you the answer for that one right there by the looks of it, but that's what your goal is. Maybe Miss Mooser will clarify what I said if you guys are confused. But that is our goal point, or like our end goal. We're creating triangles from going from corner to corner. That is our goal. We created two triangles. There we go. All right, and now we are going to sum up the interior angles of the polygon. All right, so we technically do not know the sum of the interior angles of a quadrilateral. But what we do know is the sum of the interiors of a triangle. We already did this. It is 180 degrees. So, given the fact that I've just made you find two triangles, you could say that we could do the sum of the interiors of triangle 1 plus the sum of the interiors of triangle 2 to get the sum of the whole quadrilateral. So that would be 180 plus 180, and that gives me 360. So the sum of the interior angles is 360 degrees. And then how many degrees is each of its regular polygon? Or how many degrees is each angle in its regular polygon? We were able to do this before with a triangle. Well, I guess I didn't do that question with the triangles. Bringing back out the triangles. Oopsie. Each regular angle. We can get each regular angle by doing the total sum of interior over number of angles. So in our case, that is the total sum of the interiors. That's 180. The number of angles we have is 3. That's giving us 60 degrees for each. Do that same I'll keep it on screen for a second. Do that same process for this one. Sum of our interiors is 360 degrees over 4 angles. Remember, the angles are formed of the corners right here. That is equal to 90 degrees. Oh, I guess that's another thing to talk about. When we start doing angles of the regular polygon, like trying to find them, you're doing the angles of the actual polygon, not like the angles inside of it. So like when I counted 4 angles, I'm talking about these 4 angles right here. Not like the individual splits. Like we have this, I'm talking about these 4 angles right here. I'm not talking about like boom, 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 boom. Because that gives us 6 angles. That wouldn't be right. So don't do this one. We're talking about the 4 angles that are formed like right away when we look at it, just like off of face value. You could think of it as like the number of sides we have on it too. That can kind of help you. But with this in mind, I want you guys to go through the other 4. And this is where the wonky video gets crazy. I'm going to have someone in the front row, or Miss Mooser, to pause the video so you guys can do the next 4. You can work together with it. Well, you can work together. But you're going to work on the next 4 shapes and fill out all the questions that go with it. I don't know. Have fun. We will go over in like, maybe like 15 minutes in class, maybe 10. For me, it's going to be right away, but for you, it's going to take a long time. Pause the video now. Welcome back. Now I have set up my paper to already have the shapes and the names of them, and then we're going to go through everything else. For instance, we're going to start with the pentagon and then work our way down. I hope you kind of notice a pattern with all of this, which is why we have this one down here and why I have 3 kind of, I'm not going to say the same, but like 3 shapes that we work with to get to this one down here. Hopefully you recognize the pattern that happened. If not, well, prepare to be surprised. All right. So first off, let's do the number of sides the pentagon has. We're going to start with the pentagon. It has 1, 2, 3, 4, 5. Has 5 sides. All right. And now the interesting part. See if you actually did this right. How many triangles does the pentagon form? I'm going to pick the top point to start, and we're going to go to each of its corners to see if it forms a triangle. Doesn't here, does not here, but it does down here, and it does right here. So, how many triangles does it form? It formed 1, 2, and 3. So I have 3 triangles from this pentagon. I'll zoom out a little bit more. So that's very far in. I'm going to zoom out. All right. And then we need to take the sum of the interior angles. So that means I'm going to do 180 plus 180 plus 180 because I have 3 triangles. That should give me 540 degrees. And then to get whatever angle this is right here, I'm going to take the total of the interior angles, so that's 540, and divide it by 5, because that's the amount of angles I have, the amount of sides I have, and that's going to give me 72 degrees. That is the amount that each angle in a regular pentagon has. This is the sum of the interior of a pentagon. This is the amount of triangles it has, the amount of sides it has, and the name. Let's go to the hexagon. Any questions? No, you don't, because I can't hear you. Very sassy today. All right, the pentagon. How many sides? Nope, we already did that. The hexagon. How many sides does it have? 1, 2, 3, 4, 5, and 6. Great. It has 6 sides. I thought my watch was dead for a second. I looked over and I was like, oh, the screen is black. Nope, it's just not bright. All right. How many triangles does the hexagon form? It forms 1, 2, 3, 4. So 1, 2, 3, and 4. 4 triangles. What is the sum of the interior angles? It is 180 plus 180 plus 180 plus 180. And that is equal to 720. And then how many angles does this pentagon have? It has 6 angles. So I'm going to do 720 divided by 6 to get the angle of the interior angle. Well, the degree of the regular angle. I don't know that off the top of my head. It is 120 degrees. The last shape that we have is an octagon. How many sides does it have? It has 1, 2, 3, 4, 5, 6, 7, 8 sides. How many triangles does it create? Starting with this point right here. It goes 1 triangle right here, 2, 3, 4, 5. Right. So we have 1, 2, 3, 4, 5, 6. 6 triangles. What is the sum of the interior angles that we have? I believe it is 900. It is not 900. It is it's 1080. I should have known. What the? I should have known that. 900 is the heptagon, which is the angle, which is the polygon that's between the 6 and 8 one. You dingus. What is the degree of a regular angle, though, you might be asking? Well, if we do 1080 divided by 8, that shall give us 135. Alright, so we just did this for the 3 polygons, well, 3 actual polygons that you have. And now I hope you guys recognize the pattern, especially with the amount of sides and the triangles that got formed. Because I gave you this for the last one, the end sides, which is an n-gon. So how many sides does the n-gon have? Well, it has n sides. Considering that it says n sides right here, n sides goes right here. Kind of just like how we knew what a pentagon was already with just looking at its name. It has 5 sides. Cool. Now this is where the pattern comes into play, and kind of hopefully you caught on by the time we got to the octagon. If we had 5 sides, we got 3 triangles. I didn't even have that in the camera. If we have 5 sides, we got 3 triangles. If we have 6 sides, we get 4 triangles. If we have 8 sides, we get 6 triangles. So if we have a non-disclosed amount of sides, the amount of triangles we're going to get is those amount of sides, so n, minus 2. That's the amount of triangles we are going to get. Are we good with this? Are we good with this so far? We're going to get that amount of triangles. Because the amount of sides that we have, 8, right here for the octagon, we have 2 less triangles. Or like, the amount of triangles we have, which is 6, is 2 less than the amount of sides we have, 8. And it works out because we tried to draw as many triangles as we could. Like with the octagon, we only got up to 6. So this can apply to anything. And the n-gon can be any polygon you would want to be. Like, it could be the 100 side, like the 100 gon or whatever, or the 768 gon or whatever. We can find the amount of triangles it has. Likewise, we can find the sum of its interior angles. So consider the fact that, going to the hexagon for a second, because I have it already written out, we have 180 plus 180 plus 180 plus 180. We could actually write this as some multiplication by doing 4 times 180 instead of doing addition. This 4 is familiar because it comes from all of the triangles that it's created right here. We have 4 triangles right here times 180 to get our sum of our interior. Let's move that down here and apply it to the n-gon. So I'm going to take my triangles, my n minus 2, and I'm going to times it by 180. That's the amount. That's the interior angles. So I took my triangles that I have, and using the hexagon, we have 4 triangles, and I times it by 180 to get its interior angles. It's this equation. Like, I did 180 plus 180. It's adding up all the triangle sums. Instead of adding, I did multiplication. So I did 4 times 180. Because I'm adding 4 times, I get 720. I got my triangles right here. Instead of adding them up all together, I'm doing n minus 2 times 180. That's my interior angles. To get the regular polygons, the regular polygon degree, like the angle measure, what we did before, like with the octagon, I took its interior and divided it by its sides. I'm going to take this interior and divide it by its sides to get its regular angle measure for, like, angle measure degree. So I'm going to do n minus 2 times 180 over n. And there we go. Perfect. This is basically not everything of 7.1, but a lot of 7.1 that we have just kind of condensed into this worksheet. There's still a little bit more, and there is one question that I skipped over, and that deals with exterior angles. For this whole time, this whole worksheet, we've been dealing with the insides, and everything we've done up until this point has been on the insides of a triangle, or insides of these polygons. Yes, it's inside the triangle, but inside these polygons. So what I first want you guys to do is flip back over your paper, and we're going to take a peek at the triangle again, or these triangles again, the triangle side. I wrote a lot on my triangle side, but hopefully you guys didn't write as much. I'm going to draw another triangle. I guess I can use the exterior one up here. So let's just say that this is a regular triangle. So everything is congruent. I guess I'll do the double congruent marks since the red one is kind of the single one. Let's just say this is a regular triangle. We can say, and if that's a regular triangle, this is 60 degrees, and this is going to be 60, and this is going to be 60. We can find the angle measure of the exterior angle by 2 ways. We can either do the way we've done it before with taking the 2 non-adjacent angles to the exterior angle and adding them up together, and that equals the exterior angle. So 60 plus 60 is equal to 120. And it is 120, like this is 120 right here. Or we could do, or not do, we can notice that this right here is a linear pair, and do 180 is equal to 60 plus x minus 60 is equal to, well, x would be 120 which is this right here. It's 120. That's what I'm trying to say. So we can find the exterior angles with the knowledge that this is a linear pair. And this might be something noteworthy to write down, that the interior angle plus exterior angle is equal to 180 degrees. They form a linear pair. So the question that I want you guys to do and kind of work through for the last little bit is, would it be possible for the sum of the exterior angles of each of these polygons in the table to be the same? Exclude the n-gon. So I want you guys in specific to look at the quadrilateral, the pentagon, the hexagon, and the octagon. And I want you to see if all the exterior angles, like the sum of the exterior angles, is the same on each of those polygons. Give you guys a few minutes, work on it. All right, welcome back. I hope that you noticed that, I hope you noticed that everything did sum up to 360 degrees. So yes, everything sums, well, I didn't even write thing, up to 360 degrees. Well, the exteriors do. This is actually a theorem that goes with this unit, and that should be everything. Like, we just did everything for the notes for this unit, not this unit, for 7.1. We are going to concrete, like, put it in like actual note packet form. If you don't know where my note packets are, which I believe I put that in like the plan, they are under my desk. They are on one of the binders under my desk. Those are the note packets. For the rest of the class, if you did not get up to this point, it's just going to be going through the 7.1 video. Depends on the time. If there's not a lot of time, don't put on 7.1 video. We'll just fill out our notes quick in class on Monday. There is no homework tonight. I'm going to spare you with no homework. So yeah, have fun. And for the rest of the class, if there's time, put on the video for 7.1. You can put it on the ViewSonic, or you can do it on your Chromebooks, either one. But we're going to write everything that we just did in our notes so you have it like readily with everything. But I'll see you guys on Monday.